So now we want to make sure that you guys know sometimes even though it looks nice to use mean value theorem, you cannot use it. One of them is when you have the function not being continuous during that interval that you're discussing. So example 3 is asking let f of x be equal to tangent of x, and we know that f of 0 is equal to f of pi. What is f of 0? Tangent of 0 is equal to 0. Tangent of pi is equal to 0. Does Rolle's theorem guarantee that there is a value c in between 0 and pi such that f prime of c is equal to 0? And it does not, because look at this picture. What we know is that between 0 and pi, the function tangent is not continuous. You're saying 0 here and pi here, and there's a discontinuity right down here. And therefore, I cannot use Rolle's theorem because continuity and differentiability part of it is not satisfied. And in fact, the derivative of tangent is secant squared of x, and it's always positive, and it's always increasing within the domain. Okay, mean value theorem examples. Example 4. Find m and m, lower and uppercase m and m, such that f of -2 is between those two values. If f is a function where f of 1 is equal to 3 and f prime of x is between -1 and 4 for all x. Oh, this one seems like to give me some limits about f prime and is asking me to find some bounds. I'm sorry, not limits, but bounds for f. What I have here is, let's see, we're in mean value theorem section, so let's check that. It tells you that f prime is basically, it exists everywhere, and it's also between -1 and 4. So f prime exists, that means f is differentiable and f is continuous. So f is continuous and differentiable because f prime exists. Is differentiable because f prime exists. And now, so I can use mean value theorem. So what does mean value theorem say? Mean value theorem says that there is a c, and c is between two endpoints. Okay, what are the two endpoints? I see an input value 1 and input value -2. So that should be what we want, between between -2 and 1. It can't go the other way around, right? -2 and 1. So c between -2 and 1 such that f prime at c is equal to f at one point minus f at the other point divided by the difference of the input. Now, what do I get up there? Up here, I know f of 1 is 3 up there, then minus f of -2. I don't know anything about f of -2. I just want to find some bounds for it. And then the bottom, I get a 3. Now, this is going to be equal to some f prime of some point c. But I know something about f prime. F prime, no matter what it is, it's going to sit between -1 and 4. So that's what I do. -1 and 4. So between -1 and 4, and this value is going to sit between them. So 3 minus f of -2 over 3. Now, can I solve the inequality and figure out an upper and lower bound for f of -2? Yeah, I can multiply both sides by 3, and then I end up with -3 is between 3 minus f of -2 and 12. Then I can subtract 3 from both sides, get -6 minus f of -2, 3 subtracted, 9. Then I can multiply all of them by a negative sign, switch the sign, and I get 6, bigger than equal to f of -2, bigger than equal to -9. This says this is the capital M, and this is the lowercase m. So basically, using the bounds for f prime and the knowledge of mean value theorem, I found that f of -2 is between